Question number 11 with the same exercise 7.3. 11th is like previous question number 10. We write the square and then whole square. So here integral of cos square 2x and then whole square. Now you know if your square, always we use double angle formula. So 1 plus cosine double of this, which is 4x, the whole by 2 and then whole square. You have used this formula, you know cos square x equals to 1 plus cos x whole by cos 2x the whole by 2. Double angle formula, one of the points to remember. You know this. Okay, now we expand this. You know this cannot be integrated, so I'll expand this. 1 upon 4 I'll keep outside. This is 1 plus, here you have cos square 4x plus middle term twice cosine 4x. Now you know this can be integrated, this can be integrated, but not this one. So what we do? Same procedure. We use double angle formula again. 1 upon 4, 1 plus double angle formula for this, which is 1 plus cosine 8x the whole by 2 plus twice cosine 4x. What I did? Just double angle formula again. The same formula. 1 plus double of 4, which is 8. Now I'll take just LCM. 1 upon 4 as it is here. If I take LCM, 2 plus 1, 3 cosine 8x plus twice cosine 2 into 2, 4. Sorry, 4 cosine 4x. What I did? Taking 2 as the LCM. So here 2 plus 1, 3. This 2 will also go here. 4. 2 plus 1, 3 and cos 4. Cos 8x. Now each of this can be integrated very easily, you know. 1 upon 4 as it is outside. Integral of 3, you know 3x. Integral of cos 8x, which is sin 8x upon the coefficient of x, which is 8. Because this is a linear function, this is also linear function. 4 as it is. This is sin 4x upon the coefficient of x, which is 4 plus c. Okay, so if you want, you can take just 1 by 4 inside. So 3 by 4x plus here 1 upon 32 into sin 8x. 4 will get cancelled. One more 4. 1 upon 4 sin 4x plus c. This is your final integral. Okay. Question number 12, you can see, not a big task. Sin square x upon 1 plus cosine x. Now here one way is you can take conjugate. I told you, if you remember, one of the points to remember, if you have 1 plus or minus cos or 1 plus or minus sine, you can take conjugate. So here one way is you can take conjugate. Just let me remind you, point number 4, if you have 1 plus or minus cos, 1 plus or minus sine, take conjugate. So one way is you can take conjugate here. So I'm just taking conjugate here. So sine square as it is. What's conjugate of this? 1 minus cosine x upon 1 minus cosine x dx upon 1 plus cos x as it is. Now what is this? 1 plus cos, 1 minus cos square, which is sine square. So both will get cancelled with this. So you are just left with 1 minus cosine x. And you know how to integrate this. Integral of 1 is x. Integral of cos is, you know, sine. So x minus cos x plus c. This is just your final integral. Next question. Cos 2x minus cos 2 alpha upon cos x minus cos alpha. Here alpha is constant, remember. And in the numerator, your double angle formulas. So what I can do is I'll reduce 2x and 2 alpha in terms of x and alpha using this formula. Cos 2 alpha, if you remember, I can write 2 cos square x minus 1, and this I can write 2 cos square alpha minus 1. What I did, I've just used the formula of cos 2x. You know the standard formula, cos 2x equals to 2 cos square x minus 1. You have used this. There are three formula. I've used one for cos function. Why I've used this? Because here your cosine function. Okay, now we can see that if you open the bracket, 1 will get cancelled, and 2 I can find outside. So you are just left with here cos square x minus cos square alpha upon cos x minus cos alpha, the whole dx. Here also dx. So now this is too simple. This is a square minus b square, so it has two factor, a minus b and a plus b. So this minus factor will get cancelled. So we are just left with here twice outside cos x plus cos alpha the whole dx. Now this is too simple to integrate. What is integral of cos? You know it is sin x. Your alpha is constant, so this is also constant. So this will come out. You are left with just 1, and integral of 1 is x plus c. It's like this, remember. Like this, if you are integrating cos alpha with respect to x, then here cos alpha will come out because it's a constant, and integral of 1. What is the integral of 1? Which is x. So cos alpha into x. So I wrote directly here, which is quite obvious for you. Next number, cos x minus sin x upon 1 plus sin 2x. If you just recall 11 trigo, this is a perfect square of some expression, you know. 1 plus sin 2x, if you remember, it is nothing but sin x plus cos x the whole square. Just recall, you know it. So I'll place here. This is not integration, remember, this is simply 11th standard trigo. So instead of this, you have sin x plus cos x the whole square. Now you must have realized why I did like this, because you take this as a t, because only this much. What's the derivative of sine? You know cosine, cos function. What's the derivative of cos? Minus sine. So I'll take this much equals to t. Put sin x plus cos x, not the whole square, only this much equals to t. So if you differentiate this, you know after substitution always you need to differentiate this. If I differentiate, what's the derivative of sine? Cos. What's the derivative of cos? Minus sine. Equals to, you know, dt by dx, or dx I'll take this side. You see now this become the entire numerator expression. So you are getting here finally 1 by t square. This is 1 dt, and this you can integrate it. You know what is the integral of this, and finally put the value of t. So this you can complete. So question number 15, that's for you, you try yourselves. I'll go to question number 16 here, which is 10 raised to 4. Now we have such power of a trigonometric function. What usually we do is we reduce into smaller function. So we write here 10 square into 10 square. Why I did like this, you will realize here. Now you keep 1 10 square as it is, and instead of 1 10 square you write sec square x minus 1. You know always when you have 10 square in integration, then we use this identity 1 plus 10 square equals to sec square. You know this identity. We already used this earlier and I mentioned this. Tan square is always replaced by this in integration. Now I'll split into two integrals. So here tan square into sec square x, that is one integral. If I open the bracket, the other integral is just tan square. What I did, just split into two integral, this into this minus tan square. Now this can be integrated very easily, as I told you, write sec square minus 1 and integrate. How will integrate the first integral? If you just notice it, it is one of the standard formula. You imagine this is like f, and then derivative of tan is sec square, so this is f dash. So if you use this formula, f raised to n into f dash, integral is raised the power by 1. So what's the power of tan here? Square plus 1, so it becomes tan cube upon 3. Increase the power by 1. The another way is you can put tan x equals to t. Minus, here instead of tan square, you can write sec square x minus 1. You know it. So here sec square x minus 1 the whole dx. And now finally this is added as it is, tan cube by 3 minus what is the integral of tan square, which is sec x, minus minus will be plus, what's the integral of 1, which is x plus c. So you have this. You try the same way this question also. Tan raised to 6 the whole dx. This for you. Try. You must try to solve this. Try cot raised to 4. Try these also. This is for you. Try same way, cot raised to 6 the whole dx. These 3 questions for you. Try, you will see. Answer would be in this form only. You will notice. Method. How do we solve these 3 questions? The same way. The way I did this, you can try same way these 3 questions, remember. There you need to use, for these 2 questions, you need to use this identity. Cot square x should be replaced by cosec square minus 1. This should be used for these 2 questions. For tan raised to 6, the same procedure more or less. Question number 17. 2 terms, single term, and obviously you should do individual division, that is distribution of the denominator. These upon this, that is sine cube upon sine square into cos square, plus this upon this, which is cos cube upon sine square x into cos square. Now individual division here, so one sign will get cancelled. You will get the sine x upon cos square. Now you know that this is a standard function. Here you will get the cos x upon sine square. You could have written from this directly, this step also, doesn't make any difference. You can drop that middle step. We did nothing, distribution of the denominator, remember. Now what is this? Sine upon cos, it is cot, and one more cos, sine upon cos is tan, and here one more cos is left, which is sec x, plus cos upon sine, it is cot, and one more sine here you are left, which is cosec x, the whole dx. And now both are standard function. What's the integral of tan x into sec x, which is sec x? What is integral of this, which is minus cosec x? Integral of cot into cosec or cosec into cot is minus cosec x plus c. This because derivative of sec is sec x into tan x, derivative of cosec x is minus cosec into cot, so we have this. Question number 18. Here, that is cosine 2x plus twice sine square x upon cos square x. Obviously we do individual division, but before that we need to use the formula of cos 2x in terms of x. So there are three formulas. Let me use this. For example, I'm using cos square x minus sin square x. Let me use this. Plus 2 sin square x is already there. Right? You know, cos 2x has three different expressions: cos square x minus sin square x, then 1 minus 2 sin square x, and 2 cos square x minus 1. Just to remind you, I've used this. Any one of these three can be used, remember, upon cos square x. So what you will get in the numerator? Minus and plus. So you are left with plus, and sin square plus cos square gives you just 1. So 1 by cos square. What is 1 by cos square? You know it's x square. And what's the integral of sec square? You know it is just 10x. So 10x plus c. That's final required integral here. So here integral of 1 upon sin x into cos cube. So one way is probably, instead of 1 you can write sin square plus cos square. If you remember, we did earlier such questions. What I did, instead of 1 I wrote sin square plus cos square. Now do individual division. This upon this. So you know here one sign will get cancelled, so you are left with sin x upon cos cube plus this upon this. So there you are left with 1 upon sin as it is, and here instead of this you are just left with cos x, the whole dx. What I did, I just differentiated, I've just placed instead of 1 sin square plus cos square, and then the individual division. So if I do individual division here, one sin will get cancelled, so sin upon cos cube. Here you are left with cos x out of square, 1 cos here and sin is already there. Now this is a standard form. You know this is nothing but just sin upon cos, which is 10, and one more cos square is left, which is sec square, plus here now at this place, you know 2 sin x cos x is the standard formula, so I'll multiply and divide by 2. So here let me keep right now this one as it is, 10x into sec square x plus this is nothing but the sin 2x. This I'll take in the numerator, so this 2 as it is, this is cosec 2x. Now you can see that the both have standard forms, both can be integrated very easily. What is the integral of the first one? You know there you have f raised to n into f dash form. So here this is like f and this is f dash. Here power is 1, remember, so raise the power by 1, so this is 10 square x by 2. Which formula I've used? This one. If you have f raised to n into f dash, then raise the power by 1, n plus 1 upon n plus 1. Here power is 1, raise the power by 1, plus 2 as it is. How do we integrate cosec 2x? You imagine this is like x because this is linear function. If you recall, integral of cosec x is log of mod of cosec minus cot upon the coefficient of x. What's the coefficient of x? Which is 2 plus c. So finally we are getting 10 square x 1 by 2 into 10 square x. This 2 will get cancelled. Log of mod of cosec 2x minus cot 2x. This is your answer. Now here you can see, if you just look at it backside answer, this is not, this is same, but this is not this what the backside given. So if you remember, here I can simplify, or I can use the alternative formula. So here after this, what I'll do is, first term as it is 1 by 2 tan square x plus integral of sec x, if you remember, this 2 as it is. The another form is this log of mod of 10 x by 2, that is 2x by 2 upon the coefficient of x, which is 2 plus c. So this 2 will get cancelled. So we'll get the half 10 square x plus log of mod of 10x. What I did, I've used the alternative formula of integral of cosec x. If you keep in form of this is perfectly right, but just I've shown that this is your backside answer, remember. Right. In subjective question, you can use any formula of sec x. If you remember, just I'll remind you, sec x has these two integrals. If you remember, cosec x, which is one integral is this log of mod of cosec minus cot, and another one is log of mod of tan x by 2. So your backside answer is in this form, remember, this angle by 2. So what I did here, this angle by 2, and y upon 2, that's because of coefficient of x, this is a linear function. At this place I have used this formula, cosec minus cot upon the coefficient of x. I'm just trying to tell you that whether you keep in this form or you keep in this form, both are correct. So here your cos and sine and formula of cos 2x in terms of cos and sine, which is cos square x minus sine square x upon cos x plus sine x the whole square. What is the important step here? That 2x we will reduce in form of x. Now your a minus b, a plus b. So you have cos x minus sine x. Here 1 plus factor will get cancelled with this. So you are left with cos x plus sine x. It's like a square minus b square upon a plus b whole square. So here a minus b, a plus b upon a plus b the whole square. So this square and this will get cancelled. So you are left with this only. That's what you are having here. Now you can see that here, what's the derivative of cos, which is minus sine, and what's the derivative of sine, which is cos. So this is nothing but in this form, f dash upon f, and what's the integral, log of mod of f. So here if I write directly, log of mod of cos x plus sine x plus c, that's your answer. I've used this formula. This is like function f, and this is like its derivative, f dash. Derivative of cos is minus sine, derivative of sine is cos. So final answer is log of mod of cos x plus sine x. 21st is too trivial. You have sine inverse of cosine x the whole dx. Now you cannot integrate it directly, you need to simplify this. So here the easiest way to simplify is this sine of pi by 2 minus x. So now this 2 will get cancelled, so you are left with just pi by 2 minus x the whole dx. Now this can be integrated very easily. First one is a constant term. Pi by 2 will come out, just 1, integral of 1 is x, so pi by 2x minus integral of x, which is x square by 2 plus c. This is required integral. Let me now go to question number 22. Question number 22. This is a very important question here. What we'll do is here we have product of two trig functions, but if you use 2CS formula, you'll get the addition, so you won't get anything. So here I'll try to set these two angles in the numerator. So I'll write here x minus a, I'll put minus sign, x minus b. Here cosine x minus a into cosine x minus b. If you just open this bracket, variable will get cancelled. This is plus, so you are left with b minus a. Now at this place, what I'll do is either you can write sine or cos, but if you write cos function, there you have cos x minus cos a, so we'll get the product of two functions. So I'll put sine in front of this. So what I did here, I'm putting sine of, this is just b minus a extra, so I need to put upon sine b minus a outside. I hope this is clear to you. Let me repeat this step again. I'm repeating this step. Here in the denominator you have cosine of x minus a into cosine of x minus b. So I'll set these two angles there, x minus a minus x minus b, the whole dx. Now if you open the bracket, it is just b minus a, x will get cancelled. And I need trig function also, so I'll apply here sine. Why am I applying sine function? Because there you will get the mixed function. So what extra you did, sine of b minus a, which is constant, I'll put outside sine b minus a. So this sine b minus a and this sine b minus a will get cancelled, so you will get exactly this. So now 1 upon sine b minus a outside as it is, I'll expand numerator using x minus y formula. So sine x into cos y minus cos x into sine y upon cosine x minus a into cosine x minus b, the whole dx. What I did, numerator just expanding. Sin x cos y minus cos x sin y. Now say individual division. Sine of b minus a outside as it is, this upon this. So in that case, these two terms will get cancelled. This is nothing but the tan of x minus a, sine by cos, minus here this will get cancelled. You can see that this will get cancelled here, this one and this one. So you are getting tan of x minus b. Now these both can be integrated very easily now. Both are standard function. Just recall what's the integral of tan. You know, it is nothing but the log of mod of sec x, sec of x minus a. This is linear function, remember. So you can imagine these are the x, log of mod of sec x minus log of mod of here also sec x, sec of x minus b plus c. What's the integral of tan x? Log of mod of sec x. Here this is like x upon the coefficient of x, which is 1 here, upon the coefficient of x, which is 1 here. So you are almost through now. This one as it is, log a minus log b, which you can write as log of a by b. So sec x minus a upon sec x minus b. This is the required integral of the given function. 23 is integral of sine square x minus cos square x upon sine square into cos square. So this you can do very easily. Two term, single term. So individual division, these upon this, sine square will get cancelled. 1 upon cos square, which is x square, minus this upon this, cos square will get cancelled. You will get the cos x square. Please check. Now both have standard functions. What is the integral of sec square? You know it is tan x, because derivative of tan is x square, minus what is the integral of cos x square? It is minus cot x plus c. So finally you will get the tan x plus cot x plus c. So A is your correct option. Next question here. In the next question you have e raised to x into 1 plus x upon cos square of e raised to x into x dx. Now here the problem with integration is with this one, remember, not with cos square, because this can be integrated very easily. If you remember, cos square x, 1 upon cos square x. 1 upon cos square is just sec square. And how do you integrate sec square? That is tan x. So here we have problem with this function. So we take this one equals to t, remember. E raised to x into x equals to t. This cos square as it is, remember here. Now once you take substitution in integration, always you need to differentiate it. On the left hand side, product rule. E raised to x as it is, derivative of x is 1. X as it is, differentiation of e raised to x is e raised to x, equals to derivative of t with respect to x dt by dx. But dx I'll take on the left hand side. So we have this. Take e raised to x common, inside the bracket you will get the 1 plus x dx equals to dt. Now you see this much is entirely numerator expression, this much. So this will be finally, this is placed by dt here, 1 upon, this was t, so this is cos square t. What is 1 upon cos square? As I explained, this is just sec square. And what's the integral of sec square? Tan x plus c. And what is, this is sec square t, so this is tan t. But what was t? T is x into e raised to x plus c. So this is your answer, option B.